We know about properties of multiplication, like commutative, associative, but let's talk about properties of multiplication that are specific to rational numbers. There's two things I want to talk about here, the identity and the inverse. And these two properties of any operation go hand in hand. And the reason why is because you have to have a multiplicative inverse to be able to create an identity, and you have to have an identity to create a multiplicative inverse. Basically, this is how it works. You pick any number you can think of. In this case, we're going to only pick from rational numbers. So pick any rational number you can think of. If you can find the inverse, then that means you found a number that when you multiply it to that number you're thinking of, you get the identity. The other way to think of it is if you have an identity, then that means you have an inverse that you can multiply to your number to create the identity. So they go hand in hand. The multiplicative identity is 1, and that's because multiplying by 1 changes nothing, and because the multiplicative inverse, which is a flipped upside down fraction, multiplied to the original number creates the number 1. So let's think about this. If I have 1 times a fraction a over b, 1 is a whole number, so I can turn 1 into a fraction with a denominator of 1. And then if I'm multiplying that to a over b, I'm just going to multiply straight across the top. So 1 times a, that's just a. 1 times b, that's just b. So we're calling 1 an identity, and the way that you can remember that is it's not changing the identity of the fraction you're multiplying. A over b, when I multiply it to 1, retains its identity. So I didn't change the value even though I did a multiplication. The multiplicative inverse for any fraction that you can think of is just a fraction flipped upside down. So if I'm talking about a fraction like a over b, the inverse would be b over a. When I multiply those two, I get a times b on top, b times a on bottom. And remember, if you can simplify, then you should. I have a on top and a on bottom, those divide off. I have b on top, b on bottom, those divide off. Now remember, you can only simplify common factors. So on the numerator, we'd be left behind with a 1. In the denominator, we'd be left behind with a 1, because 1 times ab is the ab on top. 1 times ba is the ba on bottom. If we divide off the common a and the common b, we're left behind with 1 over 1, which is just 1. So again, the identity. So the way to think of these two properties is that multiplying a number by its inverse creates the identity. So you can't have an identity without an inverse. You can't have an inverse without an identity. They go together very well. Multiplicative inverses are very useful, especially when solving equations, because they can help us get rid of fractions, turning them into 1, essentially. So we're going to practice finding the multiplicative inverse. I've got 5 different numbers written on the screen. If it's just a simple fraction, we will flip it over. So for 2/3, the multiplicative inverse would be 3/2. I just flipped it over. And we can check to make sure that it is the multiplicative inverse, because when we multiply them, we get 6 over 6, which is equal to 1. What about -2/5? Well, when we flip -2/5 over, it would become 5/2. But the negative also needs to be there, because the identity is +1, not -1. So if we're looking at -2/5, maybe we look at it as -2 over 5. So then I would have -2 in the denominator. And when I multiply those, I get -10 over -10, which is equal to 1. I could have also looked at -2/5 as 2 over -5. And then my multiplicative inverse would be -5 over +2. I still get -10 divided by -10. So the point here is the multiplicative inverse can be written in different ways when you have a negative, but it needs to include the negative no matter how you look at it. What about for a whole number 4? I'm saying that the multiplicative inverse is just flip the fraction upside down, but 4 is not a fraction. So to fix that, we're going to turn that into a fraction, 4 over 1. Then the multiplicative inverse is just that fraction flipped upside down. We get 4 over 4, which is equal to 1. What about the number 0? I can turn 0 into a fraction, 0 over 1. But if I try to flip that fraction upside down, I get a 0 in the denominator, and that's not allowed. We cannot divide by 0. Which means the number 0 does not have a multiplicative inverse. I'm going to write DNE for does not exist. We're looking for multiplicative inverse, and the number 0 does not have one. Lastly, we have a mixed number, 6 1/2. Now, for a mixed number, we can't simply flip this upside down and write that that's the multiplicative inverse. Notice that 6 1/2, only the 1/2 is a fraction that could be flipped upside down. So what we have to do with a mixed number is turn it into an improper fraction. So remember, we multiply the denominator to the whole number and then add the numerator. So 2 times 6 plus 1, that's 13 over 2. Now we can flip that upside down to make the multiplicative inverse. 13 times 2 would be 26. 2 times 13 is also 26. So again, we get that identity 1.